explaining the so-called quadratic sequence, we use this as an example. What we established, or rather the question was, find the next two numbers in this sequence. So we picked up that the number they added onto 3 to get the 5 was 2, added onto 5 to get a 9, 4, added to the 9 to get a 15, 6. So now we see a pattern about the first line of differences, that is 2, 4, 6. So obviously the next number here would be 8. Now, one other thing that you need to realize is that like how they got the 5, as I said, they basically added the 3 to the 2 and they got the 5. How they got the 9? They added the 5 to the 4, they got the 9. How they got the 15? They added the 9 to the 6, they got a 15. So therefore, how to get the next number would be 15 plus 8 gives us 23. Right? To find the next number, we know that what comes after 8 has to be 10 on the first line of differences. So obviously to get the next, we go 23 plus 10 gives us 33. All right, so that's how we go about this. So that's how we find the next two terms, right? What we also realized about this pattern is that like the second difference is constant. That is, they add the same number between the successive terms from the first line of differences. Such a pattern is what we call the quadratic pattern. Why? Because it's got a constant second difference. Are we all happy with this explanation? Kanya, are you happy with this explanation for quadratic sequence? Yes? You're happy, yeah? Proper stuff. Right, so yeah, this is what we call a quadratic pattern. As you see the thingy, the definition at the top. So yeah, so now the question was, as I said, find t, basically, or find t5 and t6. We used that process to find those two terms. Now, whatever question comes and says find t100 on this specific number pattern, it will take you quite a long time until you get to the 100th term. But as you can imagine, we do have a shortcut to this in the form of a formula. And that is the general formula for a quadratic pattern is Tn equals an squared plus plus bn plus c. Now, it is not a coincidence that this is similar to f of x equal to ax squared plus bx plus c. The format of a quadratic function is literally the same thing. So quadratic pattern is just a quadratic function, but they just present in a different way. So that's why we have it like this with the n's instead of the x's. Are we all good? Yes. Right. So we're good. So now, so this is the general format of it. So all you have to do on your side is to find the value of a, the value of b, and the value of c. How do we find those three values? We use some three formulas. Now, these formulas are not in the formula sheet. You've got to know them by heart. The same way you're able to memorize lyrics of an album, there's no way you can't fail to memorize three formulae. So the first one says, it says 2a equal to second difference. That is the first. The second one says 3a plus b equals first difference. I'll explain each one shortly. Then the last one says a plus b plus c equals t1, term 1. So you're going to use these three formulae, 1, 2, 3, to find the values of a, b, and c. What they mean by second diff is just this constant second difference, this 2, right? In this case, first difference is just the first number on the first line of differences. The first number on the first line of differences. Then T1, we all know that it means first member of a sequence, and that will be that first term there. All right? Sharp. Now, let us go ahead and find A, B, and C. Why are we interested in finding A, B, and C? It is because I asked you a question, find T100 for me from this pattern. We'd agreed that it would take us quite a long time to get to the answer. And then mathematicians have come up with a shortcut, which is this formula, right? So now how do we use this formula? We have to first find the values of A, B, and C using these three formulas. Good. We move. Um, let's find A first. We're going to use the first formula. We're going to go 2A equals second diff coincidentally is 2. It's not always 2, could be 3, could be 4, could be whatever number, right? It's just a coincidence that we have it as 2 in this case. So therefore A will be equal to 2. We divide both sides by 2. 1, sorry. We divide both sides by 2. Okay? That is A. How do we find B? We're going to use the second formula. We're going to go 3. We substitute our A. We find it to be 1. Plus B is what we're looking for. First difference, as I said, is the first number on the first line of differences. In this case, 2. It is just a coincidence that these two are the same and that they are 2. Okay, so we've got 3 plus B equal to 2. Take the 3 to the other side, it becomes a negative. Therefore, our B will be equal to minus 1. Lastly, we find the value of C. We're going to use the third formula. Our A, we substitute our A. We found it to be 2. Our B to be minus 1 plus minus 1, which is just minus. Our C is what we're looking for. T1 is the first member. That is 3. So therefore, C equal to 3. So you have successfully found the values of A, B, and C. You can go ahead and substitute them. Tn equals A is 1 n squared. B is minus 1, and C is 3. So we are able to use this formula to find T100. Before we find T100, let us see if this formula works if we try to find T4. 1, 2, 3, 4. Let us see if it will give us 15. In place of n, we put 4. We're just testing it quickly. That's what you should also do in the exam on a rough piece of paper. So in place of n, I put 4. Put 4. So this will give me 16 minus 4 plus 3, which is just 15. So therefore, this formula works. So we can confidently find T100. Can you guys do the calculation for me and tell me the answer? Let's go, Kanya. Let's go. Let's go, Khatib Jr. Let's go, Lwandle the Ocean. Ek wag vir julle. Let's go. What is the answer there? You can type it quickly, Khatebe, because the network is cutting you. Type it, Bozayam. It is 9,000. Can you guys tell me the answer? Because let's see. Okay, there. Okay, guys, let us be interactive. Let us be fast. Okay, so there's no reason for you to take 30 seconds to find the answer to this thing. No, don't do that. If you're doing this now, then you're gonna do exactly the same in the exam, and then you're gonna say maths is difficult. So please, can you guys be responsive? Can you be interactive? Can you be fast? You guys remember adults now, ne? I can actually shout at you because you guys are old enough. Like literally, I can. Okay, sharp.